Hi, here's the solution to example 3 in Force Notes 3. Here you're pushing your kitchen table. If you're pushing a piece of furniture and it's shorter than you are, your horizontal push across the room also has a downward component. And so that's what we see in this diagram. I've drawn P really big so that it's easy for us to see those force components that I'm going to need to use, because right there is a negative 30-degree angle. I would call that negative 30 because it's in the fourth quadrant, but we'll have to watch out for signs. We don't want to automatically stick negative 30 in if we're already choosing to make this downward component called PY a push that's in the negative direction. So my other forces are normal up because the floor is still supporting it, the weight down, and friction in the opposite direction of my push. So I'm going to start off trying to find mu by summing all the forces. So let's see, I guess I'll sum all the forces in the y direction. So you can start off sigma y, or you can start off MA, just remember you want the Y acceleration there. So in the Y direction, I have the normal up, I have weight down, and I have PY down. Okay, so the normal up is balancing two downs. So let's see, if I try to find the normal, it's going to be equal to the sum of those two downs. And the Y component will be P times the sine of 30 degrees. I'm going to use an absolute value for 30 degrees because I've already added a negative sign up there. So if I now put my mass in, it's 35 kilograms for that table times 9.8. Here's the push of 425 times the sine of 30 degrees. I can get a calculation here for the normal force, which is pretty important if I'm going to work to find the coefficient of stickiness. So 35 times 9.8, and then adding 425 times the sine of 30 degrees, because this is in the Y direction. I want to work with the Y component. So my normal force is 555.5 newtons. That's unrounded. Keep that unrounded. I may need to use that soon. So mu is supposed to be the ratio of, you just rearrange the friction is fun equation, the force it takes to drag an object, I like to think of it as, divided by the force it takes to lift an object. So I found out how much force it takes right there, okay? Think of it that way anyway. And now what I'm going to have to do is find friction. So therefore, I'm going to have to sum the forces in the x direction. So I can start with sigma f, or I can start MAX. My list is a little shorter here. It's just friction one way, but friction's my unknown, so I think I won't put a sign on that. Friction is in a tug of war with the push in the x direction. All right, so the table's mass is 35 again. The acceleration this time is 2 meters per second because that's in the x direction. So you can see that I have 70 as my net force, and friction plus the push of 425, this time times the cosine of 30 degrees. So we'll solve for friction now. Please do that if you haven't done it yet. So now that I have all that typed in, I have negative 298.06 if I want it unrounded. They didn't ask me to report it, so I'll just leave it unrounded, but I'll go to an absolute value to get the coefficient of friction or the coefficient of stickiness. So this coefficient equals, dividing now by 555.5, my normal force, 0.5365, etc. Can round it like that. Coefficients are often reported with 4 significant figures. So there you go. There's a solution to Force Notes 3, Example 3.